Hi everyone. We are going to do a video lesson as a child for a couple of these. So we'll start with 5.1. This is in OneNote, Chapter 5, Lesson 1. And while I'm going through this, you will probably want to split your screen between this video and your OneNote so that you can take notes while you're watching and listening. So I'll give you a couple seconds to do that or pause. Okay, so for lesson 5.1, we are moving into dealing with triangles. You're going to see a lot of what we did with parallel lines cut by a transversal or two lines cut by a transversal when we deal with triangles. And then some other things we also need to remember about triangles is that the sum of their angles is 180 degrees. Okay, so we will prove and use theorems about angles of triangles in order to know if you have met that learning target. You will know that you can classify triangles by their sides and their angles. You will be able to prove theorems about the angles of triangles, and you will be able to find interior and exterior angle measures of triangles. So those exterior angles are something we haven't dealt with before geometry. So that will be brand new. All right, let's scroll a little bit. Most of this should be review. We are classifying triangles by their sides and by their angles. When we classify triangles by their sides, if a triangle has no congruent sides, we call it a scalene triangle. If a triangle has at least two congruent sides, it's known as an isosceles triangle. And if a triangle has three congruent sides, all sides equal, that's an equilateral triangle. Now you may notice that the isosceles says at least two, which means that every equilateral triangle is also an isosceles. We can also classify our triangles by their angles. Any triangle that has all acute angles. All three angles are acute, and if we recall, acute means that they are between 0 and 90 degrees. Um, I wrote that wrong. Hold on. So all of the angles x are greater than 0 degrees but less than 90 degrees. I don't like where I wrote that. It's hard to see. We'll try it for the third time. All the angles are greater than 0 but less than 90. Those are acute triangles. Triangles that have one right angle, those are known as right triangles. Make sure that you are looking for the marked right angle. Don't assume because it looks right that it is. It has one angle that is exactly 90 degrees. An obtuse triangle. What color have I not used yet? An obtuse triangle has one obtuse angle, only one. And the reason it can't have more than one is because obtuse angles are greater than 90 but less than 180. And if you had more than one angle that was more than 90 degrees, then you wouldn't have a triangle anymore because the sum would be greater than 180. So an obtuse angle is greater than 90 but less than 180. So that's an obtuse triangle. And then this is the one that might be new to you. And this is an equiangular triangle. And that means all three angles are congruent. This is also an acute triangle. An equiangular triangle is always acute. And if we think about it, if we know there's 180 degrees in the triangle, that sum of the interior angles is 180 degrees. If we divided that by 3, each angle would be, I don't have a good color to match that. Each angle, let's see if I can find one here. Nope, I'll just go with my light blue. Each angle is going to be 60 degrees because 60 plus 60 plus 60 is 180. So each angle will be 60. All right, so how can we classify? We need to classify by sides and angles, and we need to look at what's marked. Note that right here, it's really hard to see, and right here, we have two sides that are marked congruent. So if two sides are congruent, it's going to be isosceles. And then it wants you to measure these with a protractor. Unfortunately, none of them are marked. We don't do much with a physical protractor anymore, but we'll take their word for it that the angles are 55, 50, and 70. And because all of those angles are less than 90, this is acute. So it is an acute isosceles triangle. And every single triangle we can label based on its angles and its sides. All right, so classify the triangle in self-assessment number 1. Classify the triangle based on its sides and measuring its angles. Well, those are all marked the same, so that is going to be an equilateral triangle. And I am going to tell you that all of those angles are also the same, so it will be an equiangular triangle. So equilateral and equiangular. Okay, moving forward to example 2, identifying a triangle in the coordinate plane. Ooh, we have our distance formula again. Remember that you can find the distance formula in on your reference sheet, which is located in resources. But in order to find the measures of the sides, we have to use the distance formula for all three sides. So here, something lighter. Here we're doing the side length of OP. So that's right here. Here we're going to do the side length OQ. So that's this one right here. And then here we're doing the side length PQ. And if we remember our distance formula, we take the difference of our two x's, square it, add that to the difference of our two y's squared, and then take the square root of the whole thing. So we see how this is done. Point O is 0, 0, and point P is negative 1, 2. So they did negative 1 minus 0, 2 minus 0. That's going to be negative 1 squared is 1, and 2 minus 0 is 2 squared is 4. So that would be the square root of 5. And if you put that into your calculator, it's about 2.2. Then for side OQ, the points are 0, 0, and 6, 3. So 6 minus 0, that's 6, squared is 36. 3 minus 0 is 3, squared is 9. 36 plus 9 is the square root of 45. And if you put that in your calculator, it's about 6.7. And then for side length, side PQ, the length, we have our points -1, 2, and 6, 3. So 6 minus -1 is the same as 6 plus 1, which is 7, squared is 49. And then 3 minus 2, which is 1, squared is 1. So 49 plus 1 is 50. It's the square root of 50. And if you put that in the calculator, it's about 7.1. No sides are congruent. So triangle OPQ is a scalene triangle. Then we check for any right angles. And we can do that by looking for slopes. And we know that the slope of of perpendicular lines, I should say the slopes of perpendicular lines are negative reciprocals. That's a review from algebra, and we talked about it in chapter 3, and it came up in chapter 4 again. Okay, so this is something that's going to keep showing its head. So when we check for right angles, we look for the slopes of the lines. So the slope of OP, we use those 2 points again, -1, 2, and 0, 0. It's the difference in the y's over the difference in the x's. 2 minus 0 over -1 minus 0 is -2. And the slope of OQ, we're using 0, 0, and 6, 3. That was 3 minus 0 over 6 minus 0. So the slope of OQ is 1/2. And then we find the slope of, where'd we go? Oh, they didn't find the slope of the last line. I guess as soon as they found negative reciprocal slopes of -2 and 1/2, they decided it was a right triangle. So that was smart without having to do the third one. But we could find the slope of PQ. So the slope, I won't use M for this. We'll just say the slope of PQ, line segment PQ, and that is 3 minus 2 over 6 plus 1, which is 1/7. So I like to be thorough, especially on that first example, so that you can see all of them. So we did find negative reciprocal slopes in 1/2 and -2. So once we see that, we know that there is one right angle, which will make this triangle a right triangle. As soon as we have one right angle, it is a right angle. So that means this triangle is a right scalene triangle. All right, self-assessment number 4. Triangle ABC has these vertices. Find the side lengths and classify the triangle by its side, and then determine whether it is a right triangle. So this will just be a yes, it is a right triangle, or no, it is not. All right, pause the video, find all of your distances. I'll give you the distance formula here. So distance is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, pause the video here and find the distance of all 3 lines. All right, welcome back. I am going to show you those distances here on the side. So Use purple. I used orange, but I should use orange. Point A is 0, 0. Goodness gracious. Don't forget the comma. Point B is 3, 3. And point C is negative 3, 3. So I'm going to find the distance of A, B, and that's going to be the square root of 3 minus 0 squared plus 3 minus 0 squared, which is the square root of 9 plus 9, which is the square root of 18. And then we'll do BC, and that is the square root of 3 plus 3 squared plus 3 minus 3 squared, which gives us the square root of 6. So 36 plus 0, so square root of 36, which is just 6. And then the distance of CA, and that's going to be negative 3 minus 0 squared plus 3 minus 0 squared, which, just like AB, is going to give us 9.9 plus 9, which is the square root of 18. Okay, so because I see that two of these are the same length, that is going to make it an isosceles triangle. And then let's see what our slopes are. So the slope of AB is 3 minus 0 over 3 minus 0, which will be 1. The slope of BC is 3 minus 3 over negative 3 minus 3, which is 0 over negative 6, which is just 0. And then the slope of CA is 3 minus 0 over negative 3 minus 0, which is 3 over negative 3, which is negative 1. And I see that 1 and negative 1 are negative reciprocals. So yes, this is a right triangle. So we would call this a right isosceles triangle. Is that number 4? Yes. Okay, so how about angle measurements? Well, all of the interior angles add up to 180 degrees. That is this theorem right here. So the sum of the interior angles is 180 degrees always. And then we can also deal with exterior angles. And if we look right here at this triangle with the blue marks, if you were to extend the triangle lines, the sides out to each end, and you're going in the same direction, those are exterior angles. So it's the angle that's created when you extend the side of the triangle past the other side. So that's an exterior angle. Okay, so very often to prove certain theorems, you might need to add a line, a segment, or a ray. That's called an auxiliary line. Okay, and our auxiliary line is right here, line BD, and that gives us parallel lines cut by transversals. And it also gives us in 2, 4, and 5, those angles all create a line. So we know that they equal 180 degrees. So we can see here how we prove that the sum of the interior angles of a triangle are 180 degrees. All right, now we have another theorem, and this is the exterior angle theorem. And what does it say? The measure of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. What does that mean? This angle, angle 1, is equal to angle A plus angle B. That's what it means to be non-adjacent. They're not next to it. Angle C would be adjacent to angle 1. So we're looking at the ones that are not adjacent. And those two equal the remainder of the line, which makes sense because the line and the interior angles of the triangle all equal 180 degrees. So how can we find that? Well, we go back to, from our very first lesson, part plus part equals whole. And in this case, one of our parts is 70, one of our parts is x, and what they equal is 2x minus 5. So 70 plus x equals 2x minus 5. Let's add 5 to each side and subtract x from each side, and we'll get x equals 65. So x is 65 degrees. Ooh, 65. 75. I better do it one step at a time so I don't make a mistake like that. Add 5 to each side, subtract x from each side, 75 equals x. So x is 75. We can check that. 70 plus x, we could find out what this is. Or we can also find out what 2x plus 5 is. So 2 times 75 plus 5, 2 times, why is it, oh, minus 5. Minus 5. So 2 times 75 is 150, minus 5 is 145. So the measurement here of 2x minus 5 is 145 degrees, and x is 75 degrees. All right, a little new vocabulary. We have had postulates, we have had theorems, and now we're going to have corollaries to a theorem. So what is a corollary? Something that accompanies or follows something else. So in math, it's a statement that can be proved easily using the theorem. So this corollary follows from the triangle sum theorem. The acute angles of a right triangle are complementary. Let's dissect that a little bit. A right triangle has one 90-degree angle. If all three have a sum of 180 degrees, and one of them is 90 degrees, that means the other two together are 90 degrees. And that's the definition of complementary. Two angles that equal 90 degrees. So in an example like example 4, if we know this is 90, and we know it's a triangle that all the sum of all the angles is 180, then we know here that x plus 2x must also equal 90 degrees. 3x equals 90, x equals 30. So this one is 30 degrees. 2 times 30 is 60 degrees. Try self-assessment number 5 and number 6. So pause this video, work them out on your OneNote page, and then come back to check your answers. Welcome back. So, on number 5, we have a triangle, and we know two of the interior angles, and we know the opposite exterior angle. We have a theorem that tells us that the exterior angle and exterior angle is equal to the sum of the two non-adjacent interior angles. So we're going to say that 3x plus 40 equals 5x minus 10. Subtract 3x from each side. 40 equals 2x minus 10. Add 10 to each side. 50 equals 2x. Divide by 2. X equals 25. So this is 40. If x is 25, then 3x is 75 degrees. And 5x is 125 minus 10 is 115 degrees. On number 6, find the measure of each acute angle. We know that 2x plus x minus 6, those have to equal 90, because if one angle equals 90 and all three of them equal 180, the other two have to equal 90. Combine like terms, 3x minus 6 equals 90. Add 6 to each side, 3x equals 96. Divide by 3, x equals 32. But it doesn't want to know what x is. It wants to know the measure of the angles. So 2 times 2 times 32 is 64 degrees, and 32 degrees minus 6 degrees is 16 degrees.